In section 8.4, we're going to look at similar triangles. Before we talk about similar triangles, I want to review the ways we proved triangles congruent. There was 5 ways we studied to prove triangles congruent, and they were side, 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 angle, side, angle, angle, side, and hypotenuse, leg. And there are 2 ways that we looked at that did not prove triangles congruent. Side, side, angle, and angle, angle, angle. Today, I want to look at angle, angle, angle. If we look at these 2 triangles, between these 2 triangles, we have a pair of congruent angles and a second pair of congruent angles. Now, I don't know how big this third angle is between these 2 triangles, but I could figure it out by taking 180 degrees minus 50 minus 25. So this last angle is 105 degrees big. Now, if you remember, when we looked at angle, 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 it didn't prove triangles congruent. What it actually did was prove triangles similar. So these 2 triangles aren't congruent. They're actually similar. Triangle ABC is going to be similar to triangle. Now I need to name the second triangle in the correct order. A corresponds to N, B corresponds to M, and C corresponds to O. So angle, angle, angle doesn't prove triangles congruent. It actually proves triangles similar. And in reality, we didn't need this third angle. Because automatically in a triangle, if we know 2 angles, that third angle is going to automatically be congruent. So we're not going to call this the angle, angle, angle postulate. We're just going to call it the angle, angle similarity postulate. So to prove 2 triangles similar, I need to have 2 pair of corresponding angles congruent. And if I have 2 pair of corresponding angles congruent, that third pair of corresponding angles will automatically be congruent. Let's look at an example that involves proving triangles similar. If we look at our given, we're given that side AB is parallel to segment DE. And parallel lines tell me about congruent angles. And in this case, I have parallel lines cut by 2 transversals. And when I have parallel lines cut by a transversal, the angles that make up that zigzag are going to be alternate interior angles. So I actually have 2 pairs of congruent angles. Angle A is going to be congruent to angle E, and angle B is going to be congruent to angle D. And if we look at this picture, in this example, the way the triangles are drawn, this angle will be congruent to this angle because they're vertical angles. So in order to prove these 2 triangles congruent, I'm going to use the angle-angle similarity postulate. And I actually have 1, to 3 pairs of congruent angles. In my proof, I only need to use 2. My first statement is going to be my first given. Now, if I have parallel lines cut by a transversal, my alternate interior angles are going to be congruent. So that's going to be my second statement. Because my lines are parallel, angle A is going to be congruent to angle E by the alternate interior angles theorem. Now remember, alternate interior angles aren't automatically congruent. They are if I know my lines are parallel. I have to have this before I can conclude this. Now at this point, I can either go to here or to the vertical angles. I'm going to go to the vertical angles. Now when I name this angle, I can't just call this angle angle C. I could call this angle angle A because there's only one angle associated with this vertex. But if I look at C, there's actually 1, 2, 3, 4 angles. So I need to be specific when I name this angle. I'm going to say angle ACB is congruent to angle, now I got to be specific when I name this angle, DCE. And those two angles are congruent because they're vertical angles. So by the vertical angles theorem, they're congruent. So I have a pair of congruent angles, and I have a second pair of congruent angles. That's enough to prove that my triangles are similar. Now I need to make sure that I name my triangles in the correct order. Triangle ABC is similar to triangle. A corresponds with E, because they're alternate interior angles. D corresponds with B, and C corresponds with C. And those two triangles are similar by the angle-angle similarity postulate. I could have written this proof differently by exchanging this statement with this statement, and again, the same reason, alternate interior angles. This was just an example of how to do this proof correctly.